Okay, so now when we do these things in images, it's really tough to convey to people what these different things mean. So if you think of like an arrow, like a bow and arrow, right? The arrow has a little pointy tip, and then like the fins on the back. Um, these X's are supposed to be kind of like the fins on the back. So it's like an arrow being shot into the screen. So this is like a field or something is going into the screen, and we're seeing the tail end of the arrow. So we could say, hey, this is like a magnetic field, which is the symbol B is the symbol for a magnetic field. No idea why. Um, the X is like the could represent a magnetic field going into the screen, or if we have a wire that's going into the screen that direction, then we could say, hey, there's a wire and current is going into the page or into the screen. Other way around, if it's an arrow being shot at you, you see the tip of that arrow right before you catch it matrix style or whatever. So as the tip of the arrow is coming at you, you just see like a little dot, right? So that's what these are supposed to be. Or if it's a rod or a current carrying wire and the current is coming out of the screen at you, that's this deal. So these are kind of a different way to represent directions when we have to do this third dimension. Like we've done uppy, downy, lefty, righty. This is the first time we've done into or out of in physics in this class. And drawing them with like the science class or math class, although sometimes kind of twist axes, that gets really messy with this stuff. So first question dealing with this. So right hand, thumb in the direction of positive charges, fingers in the direction of the magnetic field, and your palm points in the direction of the push on the charges. So again, just saying out loud to folks, it's now a little bit after 11:02. So if you have to go, I'm perfectly fine with that. I take no offense. You got to go, you got to go. If you have time and you want to work through this, we can work through this. So the magnetic field is into the screen. Positive current is to the top of your screen. So twist and turn your right hand. So twist and turn your right hand so your thumb points in the same direction as positive current. So right hand, and it says my current is to the top of the screen. So current is to the top of the screen. So I'm pointing my thumb up towards the top of the screen. And then the magnetic field, those X's mean that the vector is going away from us into the screen. So my fingers should be pointing into the screen. And I don't know if this is reversing images to you. So let's see. So for me right now, my palm is pointing to the left. Am I pushing to the left for you guys too? No, it's doing it opposite for you. Let's see, there's probably a way to switch that around. But so my thumb is pointing up, my fingers are into the screen, and then when I do that, for the view that I'm looking at, let's see, we'll go like this here. If this is the wire, we'll go there. This is the wire, current is going up, the magnetic field is into that screen, so that way. So I am pushing to the left. Hopefully that works. Does that work for you guys? The perspective, I think. So if this is the wire, current to the top, magnetic field into the screen, and the force would be to the left, the direction of my palm. So I go that way. All right. Now, if we do this version, a slightly different representation of similar things. So if we just have charges moving to the right, and we have a magnetic field into the screen. So the magnetic field is into the screen, and the charge is moving to the right. Then we find the force. So I'm going to pretend that like this is my screen again. Okay. So if this is my screen, I have the magnetic field into the screen. So my fingers point into the screen. and they show the positive charge moving to the right. So my fingers can point into the screen and my hand can be turned a bunch of different ways. But now my finger's pointing into the screen and my thumb needs to point to the right. So I need to kind of twist my body or whatever, and there. And now my palm is facing up and the force on the charge is up. So this should be, and I should say up towards the top of the screen. My apologies for um, saying that messy. And so, and here's the kind of crazy thing that like where one of the ways that this is um, one of the natural places where this occurs is like the northern lights. You've heard of like the aurora borealis, right? So the earth has a magnetic field, and at the north and south poles of the earth, where the magnetic fields are the strongest, as ions or charged particles come streaming at us from the sun, right? The sun is this big nuclear reaction, all this stuff is happening, and we have all these charged particles just streaming at us, being thrown at us from the sun and from the rest of the universe, primarily the sun. Well, at the north and south pole, where the magnetic field is the strongest, as those charges come barreling into the earth, they come in, charges are coming this way, and the magnetic field is that way. And these charges end up kind of getting bent into different directions. And as they change paths, they emit light as all stuff happens. And so that's how we see the northern lights, or the aurora borealis, is produced by the bending of those charges as they come at the magnetosphere. Um, it's also a principle that's used in a variety of different physics applications, but sometimes like the natural things are interesting. It's 11, almost 11:10. So again, some folks are hanging up as they need to go, perfectly fine by me. So now here, um, now we're saying that we have this positive charge moving to the right. So I'm gonna, again, think of this as my screen. So my positive charge is moving to the right, and I can rotate my hand in a bunch of different directions and still have my positive charge going to the right, but the positive charge is going to the right. And this shows the magnetic field going to the top of the screen. If this is my screen, magnetic field to the top of the screen. And now for this, my palm is coming out of the screen. So the force on the charge would be this way. So as the charge is going this way, magnetic field here, the push on the charge is that way. And what this means is that the charge would end up actually taking this curved path as it goes through. So the force would be out of the screen, same direction as my palm was facing. Okay. Oh, what is B? Sorry, thank you for asking. These things that um, I adapted this from previous years, and in previous years we talked about that more explicitly. So the magnetic field B, B is the symbol that we use for magnetic fields. So like if we use V for velocity or F for force, and then we got into some strange things where we used I for current, right? Like where does I come for current? Yeah. Um, B, for some reason, B is the symbol for magnetic field. It's not measured in B, but B for magnetic field. So um, when we say the magnetic field B, I mean that's just what we're calling the magnetic field, the symbol B. Okay, and there we are. And there was another question asked and then a never mind. So how long did this take us to complete? I'm going to say probably about 30 minutes, because we went through and had some preliminary discussions at the beginning. It's now 10 after, so we'll try that. And then if you hit submit, you can then check your scores, click view score, and open your responses in a new tab. Check to see what you got right, what you got wrong. Let's see if we did any brain cramping here. View score. And I like, when I do this, I like hitting right click and then opening it in a new tab, because then I know I can go back here to edit my responses and I don't have a bunch of other messy stuff to try to figure out. So, hey, 10 out of 10. Woo! So there we go. That's that. Any questions on any of that? Okay, so I'm only giving you this one assignment. I mean, we've been doing this for 40 something minutes. You know, ballpark. The form itself only took about a half hour, but we've been here for about 40 minutes. That's the only thing for today. This is related to power generation, electrical energy generation. We'll talk about that more tomorrow. That's all I got for you. I'm going to hang on and just kind of babble nothingness while folks hang up and take off. So if you do have questions, hang out, wait for folks to leave. You can ask them. Or it can just be me sitting here staring at a screen, talking to myself, nodding my head.